In example 3, we want to determine the orthocenter of a triangle with vertices at A, -4, -2, B, 12, 6, and C, 8, 12. So the first thing we want to do is determine the slope of line segment AB. Well, if we let the coordinates of A be x1 and y1 and the coordinates of B be x2 and y2, then the slope is y2 minus y1 over x2 minus x1, which is 6 minus -2 over 12 minus -4. So the slope of AB is 8 over 16, which is 1 over 2. Now remember, the altitude will be perpendicular to the side of the triangle, so we know that we want to use the perpendicular slope, which is the negative reciprocal, -2 over 1, and that is simplified to -2. Now, what point will that altitude go through on the triangle? It will go through the far vertex. That's what altitudes do. They're perpendicular to one side going through the far vertex. So we want a slope of -2 going through the vertex C, 8, 12. So we know y equals mx plus b is the equation of a line. The slope is -2, and we sub in 8 for x and 12 for y. Doing that gives us a b value of 28. And so the equation of the first altitude is y equals -2x plus 28. And there we go. We wanted a line perpendicular to AB. So that's what we have, a slope of -2, but going through the far vertex. And what we've now done is we've determined the equation of the altitude from a vertex perpendicular to the far side. All right, well, moving on, we want to determine the slope of AC so that we can find its altitude. So using the coordinates of A as x1 and y1 and the coordinates of C as x2 and y2, we get that the slope of AC is 14 over 12, which is 7 over 6, which means the perpendicular slope is -6 over 7. Now that we have this perpendicular slope to AC, we're going to want to take that perpendicular slope and make sure that we extend a line perpendicular to AC, but through the point B, 12, 6, because that's what that altitude would do. So, doing that, putting it through the point 12, 6, we get y equals -6/7 x plus b, which means 6 is -6/7 of 12 plus b. Solving for b lends us to the situation where we'll multiply each term by 7, meaning 42 will equal -72 plus 7b. Proceeding along, we'll get b is 114 over 7, which means the equation of the second altitude will be -6/7 x plus 114 over 7. Okay, so the first altitude was found, and now the second altitude has been found. And our job is to find the point of intersection. That point of intersection will be the orthocenter. And you may say, well, how did we know which two altitudes to use? Amazingly, if we had decided to use this third altitude instead, perpendicular to the side length BC, extending through A, it would have actually intersected in exactly the same point, one of the neat properties of triangles. So again, all we're going to do now, we have the equation of each of these two altitudes, and we're going to determine where they intersect using the method of substitution. Okay, so since the first line is y equals -2x plus 28, and the second line is y equals -6/7 x plus 114 over 7, we set those two expressions equal to each other. We have a lowest common denominator of 7, so we multiply both sides by 7. 7 times -2x is -14x, 7 times 28 is 196, 7 times -6/7 x is -6x, and 7 times 114 over 7 is 114. Doing some relatively straightforward math from that point on, getting our x terms on one side and isolating x, we get x is 41 over 4. Okay, well that hasn't given us the point yet. We still have to substitute that value of 41 over 4 into either line equation. So we'll use the equation y equals negative 2x plus 28 because it seems a little simpler than this one. So we'll take that point, that value of 41 over 4, and plug it into the expression y equals negative 2 times x plus 28. Doing that leads us to the conclusion. Negative 82 over 4 simplifies to negative 41 over 2. 28 over 1 becomes 56 over 2 to get our common denominator, and we have a y value of 15 over 2. So our orthocenter is at 41 over 4, comma, 15 over 2. And that is where those two altitudes meet. 41 over 4, which is slightly greater than 10, and 15 over 2, which is about 7.5.